right, so in the last problem, we had something like, I don't remember what it was, 2 times the square root of 3 over 3 times the square root of 10, something like that. This is all multiplication in the denominator. So in this problem, we're rationalizing a denominator that contains 2 terms. So you've got addition, or it could be subtraction, but it's got 2 terms in the denominator, and we can't have that square root of 5 down in the denominator. That's the problem. So we have a different approach, and we use what are called conjugates. So conjugates work like this. If you have a plus b, then the conjugate is a minus b. Or if you have 3 minus the square root of 2, the conjugate would be 3 plus the square root of 2. So what's happening is the addition or subtraction sign is changing. And that's what we're going to use to simplify. Okay, so that's what a conjugate is. So right now we have 4 over 1 plus the square root of 5. So what we're going to do is we're going to multiply by the conjugate of that denominator, 1 minus the square root of 5. Now you have to do it in the numerator as well as the denominator. Okay, so the conjugate of 1 plus the square root of 5 is 1 minus the square root of 5. Okay, so now we're going to multiply stuff out. In the numerator, I might not multiply it. I might just leave it. 4 times 1 minus the square root of 5. And there's a reason for that, but we'll see it later. Now what happens in the denominator? You're going to use FOIL here. You're going to go 1 times 1, which is 1. You're going to go 1 times a negative square root of 5, which is negative square root of 5. You're going to go square root of 5 times 1, which is positive square root 5. And then you have finally a square root 5 times a negative square root 5, which is negative square root 25. Now, when you simplify that, these cancel out because you got 1 negative and 1 positive. Those are going to cancel out and make 0. That's why this works. Okay, so 1 minus, and then we know the square root of 25 is 5, so 1 minus 5. So you don't have a radical anymore. But what's 1 minus 5? Negative 4, right? Okay. So the reason I didn't distribute the 4 here is because look what's going to happen. These are going to cancel. So I'm going to have a negative 1 times 1 minus the square root of 5. Now, I probably wouldn't leave it that way. I would go ahead and distribute. I'd probably make it, let me scroll, negative 1 plus the square root of 5. And I would probably leave my answer like that. Usually we put the radical at the end. Now, one thing I didn't mention in another video, a lot of textbooks will handle this a little bit differently. But let's say you have the square root of a to the 5th power, okay? Well, that's fine. Okay, and we did that. We said, oh, well, it's like a. So 1, 2 pairs, so a squared times the square root of a. That's fine. But now let's say you have the square root of a cubed. So a, that's 1a on the outside and then 1a on the inside. When you have a variable and it's got an odd exponent on the outside, when you're simplifying these radicals, sometimes they will put absolute value signs on that, okay? Now, a lot of textbooks at some point they'll say, don't worry about the absolute value, we're just going to write it, we'll just assume that a is positive, okay? But I noticed in the textbook they do use that notation, so it only happens if you have an odd exponent on that variable when it's coming out of the radical. Let me give you another example because I know it's kind of confusing. Let's say you have the square root of b cubed c to the 8th. Oops, 8th. Okay, so, well, b cubed, that's not very exciting. Okay, you get a b on the outside, but you only get 1 b. So that's going to have an absolute value. You're going to have a b left over on the inside. Now what about the c to the 8th? That's going to become c to the 4th. You don't have to put it in the absolute value because see, it's already going to be positive because it's got an even exponent on it. Okay, so I just wanted to mention that. I imagine somewhere in the book they're going to say don't worry about the absolute value. And to be honest, this whole chapter we're just kind of reviewing some basic tools to use.